So in this lesson, we're going to discuss solving one-step equations. What does it mean to solve an equation? Well, to solve an equation means to determine the value for the variable that makes the equation true. So for example, in this equation here, x plus 3 equals 5, there's only one value for x that makes this equation true, and that is 2. Because 2 plus 3 equals 5, and 2 is the only number that I can add to 3 that would give me a sum of 5. So the solution to the equation x plus 3 equals 5 is x equals 2. So in this lesson, we're going to look at the process for solving these types of equations. Now granted, this equation was very easy to solve in your head without having to write or show any work, but the goal of this lesson is not necessarily to get the answer, it's to understand how equations work and the process for solving equations. Because as you move throughout algebra, the equations will become more and more complex, and you will not be able to solve them all in your head. You will have to understand the process and steps and be able to use them in the correct order. So one of the first things that we need to understand about equations is that the equations have a middle, a left side, and a right side. So your equal sign is the middle, the center of every equation. Even if it doesn't look like it's in the middle, it is the middle of your equation. And then you have a left side and you have a right side. Now the reason why this is important is because the goal of solving any equation is to isolate the variable. And what that means is to get the variable alone on one side of the equation. So you need to be able to look at an equation and understand which side is the left side and which side is the right side. In this equation, we see that on the left-hand side of my equation, I have x plus 3, and on the right-hand side, I have 5. So my x is on the left, but it is not the only term on the left. The plus 3 is also on the left. So in order to isolate x, I need to get rid of or eliminate plus 3. And the way we do that is by using the inverse operation. So the inverse of addition is subtraction. So I'm going to subtract 3. Now, equations must always be balanced, which means that if I do one thing to the left side of the equation, I must also do that to the right side of the equation. So if I am subtracting 3 from the left, I must subtract 3 from the right. So we draw a line across, and 3 minus 3, that is 0, or it cancels out because adding 0 doesn't do anything. So x plus 0 is just x. Equals, and 5 minus 3 is 2. So I achieved my goal. I isolated my variable, x equals 2, and this is my solution. All right, so let's go ahead and take a look at some addition equations here. First, we have x plus 4 equals 10. So the middle, the center of my equation is the equal sign. I have x plus 4 on the left and 10 on the right. So my x is on the left, and I also have plus 4. So in order to isolate x, I need to eliminate plus 4. And the opposite of addition is subtraction. So I can think of this as 4 minus 4. I could also think, if I think positive 4, the opposite of positive 4 is negative 4. Same thing. And remember the rule. Whatever we do to the left, we must do to the right. So if I'm going to subtract 4 from the left side, I must subtract 4 from the right-hand side. So first, what's going on here, where I have 4 minus 4, this has a special name. It's called the additive inverse. And the additive inverse means that whenever you add a number to its opposite, the answer is always 0. So positive 4 plus negative 4, or 4 minus 4 equals 0. And that kind of cancels out because x plus 0 equals x. When you add 0 to something, it doesn't change. So this leaves me with an x on the left-hand side. And on the right-hand side, I have 10 minus 4 equals 6. Now, here, where I subtracted 4 from both sides, this is called the subtraction property of equality. The subtraction property of, and I'm just going to put EQ here for equality. And what that means is I can subtract anything I want from an equation as long as I subtract the same thing from both sides. So if I'm going to subtract 4 from the left, I have to subtract 4 from the right. That is the subtraction property of equality. Now, I can test my solution here by substituting my solution for the variable in the original equation. So I have here x plus 4 equals 10, and I found that x is 6. So now I have here 6 plus 4 equals 10, and when I combine 6 and 4 on the left-hand side, I get 10 equals 10, which is true. So I know that my solution is correct. Let's take a look at the next example here. I have here 2 equals 12 plus y. Again, my equal sign is the middle, so 2 is on the left, and on the right I have 12 plus y. So y is my variable that needs to be isolated, and I need to get rid of this 12 in order to isolate it. So keep in mind here, this plus sign in between the 12 and the y is here because y is positive. But I need to know what kind of numbers is 12. Is it positive or negative? So in order to do that, I always have to look in front. So are there any signs in front of the 12? No. So that makes it a positive 12. So what that tells me is, in order to get rid of positive 12, I have to subtract 12. And because of the subtraction property of equality, if I'm subtracting 12 from the right-hand side, I have to subtract 12 from the left-hand side. So 12 minus 12, that cancels out, leaving me with, on the right-hand side, a y, and on the left-hand side, 2 minus 12. This is positive and negative, so we subtract and keep the sign of the bigger number. So 2 minus 12 equals negative 10. Again, I can go ahead and substitute this into the original equation to see if I'm correct. So I have here 2 equals 12 plus negative 10. 12 plus negative 10 is the same thing as 12 minus 10, and 12 minus 10 is 2. So I have 2 equals 2, and that is true. All right, so now let's look at some subtraction equations. First one says a minus 6 equals 3. So we see that a minus 6 is on the left and 3 is on the right. So in order to isolate a, I need to get rid of minus 6 or negative 6. So what is the opposite of minus 6 or negative 6? That would be positive 6 or plus 6. So I'm going to add 6 to the left, and whatever we do to the left, we must do to the right, so I have to add 6 to the right as well. Now this is called the addition property of equality. Because this time, instead of subtracting the same thing from both sides, we're adding the same thing from both sides. So we have here negative 6 plus 6, additive inverse, that cancels out, becomes 0. This leaves me with an a on both sides, equals, and on the right hand side I have 3 plus 6 equals 9. So this next example here, we have negative 3 equals negative 8 plus b. We see that I have a negative 3 on the left and negative 8 plus b on the right. So in order to isolate b, I need to eliminate this negative 8. Now, be careful on problems like these because many students have trouble here. They see this plus sign in between the negative 8 and the b, and they think, oh, that's addition, I need to subtract. But you have to be careful because we are not eliminating positive b, we are eliminating negative 8. This plus sign is here because b is positive. But we want b to be positive. We need to eliminate the other term, and the other term is negative 8. Because when you're determining whether or not a term is positive or negative, you always have to look in front of that term. So in front of this 8 is a minus or a negative sign, making it a negative 8. So in order to get rid of negative 8, I have to add 8. And if I'm adding 8 to the right, I have to add 8 to the left as well. So over here, negative 8 plus 8 cancels out. This leaves me with my b on the right hand side. And on the left, negative 3 plus 8, different sign, subtract, and keep the sign of the bigger number. So this equals positive 5. Let's go ahead and check this one. So I have here negative 3 equals negative 8 plus whatever b is, and we found that b here was 5. So what is negative 8 plus 5? Again, different sign, subtract, and keep the sign of the bigger number. So we end up with negative 3. So we have negative 3 equals negative 3. So that is true. All right, so let's take a look at some multiplication equations. Take a look at this first example here. 4x equals 36. You see how there's no symbols in between the 4 and the x. That means this is multiplication. So this means 4 times whatever number x is equals 36. Now you probably already know the answer, but let's go ahead and review the process so that you can understand it. So as always, I have to isolate the variable in order to solve this equation, which means I need to get rid of 4. Now in this case, 4 is not being added to or subtracted from x. This is multiplication. So how do we undo multiplication? By division. Now since we are undoing multiplication here, we are not going to change the sign. You may have remembered when we were undoing addition, you would subtract. So you would change the plus to a minus, right? And when you were undoing subtraction, you would add. So you would change the minus to plus. But here, we're not undoing addition or subtraction. We're undoing multiplication. So it's very important to understand that when you are undoing multiplication or division, you keep the sign. So x is being multiplied by this positive 4. So the way I'm going to undo that is I'm going to divide by positive 4. Now, just like before, whatever we do to the left side of the equation, we must also do to the right. So I have to divide the right by 4, and you can see that I'm writing division here as a fraction. Now this is called the division property of equality, because I am dividing both sides by the same number. So here, 4x divided by 4 equals 1x, or just x. So that's how my x is isolated. And on the right, 36 divided by 4 is 9. And I could quickly test that out by writing 4 times whatever x is equals 36. And I found that x is 9. So what is 4 times 9? 36. So 36 equals 36. That's true. I know that my solution is correct. Let's take a look at the next example here. Here we have negative 5x equals 40. And again, this x is being multiplied by negative 5. Some might get confused and see that negative and think it's subtraction. If the negative were between the 5 and the x, or if there were a plus sign here between the 5 and the x, then it would be subtraction. But it's not. You see how the negative 5 is right next to the x with no symbols in between? That's multiplication. So how do we undo multiplication? By division. And like I just said, when you're undoing multiplication or division, you keep the sign. So how do we undo multiplication by negative 5? We're going to divide by negative 5. And since I'm dividing the left by negative 5, I have to divide the right by negative 5 as well. So negative 5x divided by negative 5, that gives me 1x, or x. And 40 divided by negative 5, that gives me negative 8. And again, I can go ahead and test this out. So we have negative 5 times whatever x is equals 40. And we plug in here a negative 8. And what is negative 5 times negative 8? That is positive 40. So positive 40 equals positive 40. That is true. All right, so let's take a look at some division equations. You see this first example here says c over 3 equals 4. Remember that a fraction is a form of division, so I can read this as c divided by 3 equals 4. So think about what that means. There was some number, it got divided by 3, and the answer was 4. You probably already know what the answer is, but let's go through the process. So how do we isolate this variable c? We need to get rid of 3. So what is 3 doing to c? It's dividing it. And how do we undo division? By multiplication. Now remember, when you're undoing multiplication or division, you keep the sign. So since c is being divided by a positive 3, what we're going to do to undo that is we're going to multiply by positive 3. And whatever you do to the left side, you must also do to the right side. In this case, this is called the multiplication property of equality. So on the left-hand side, I have 3 times c over 3. These 3's cancel out because 3 divided by 3 equals 1. So this leaves me with a c on the left-hand side. And on the right-hand side, 4 times 3 equals 12. I can check that here by writing my original equation. C over 3 equals 4. And if c is 12, so if I look at the left-hand side here, what is 12 divided by 3? It's 4. So I have 4 equals 4. That's true. Take a look at this next example here. I have negative 11 equals d over negative 2. Again, this is d divided by negative 2. How do I undo division by negative 2? I'm going to multiply by negative 2. Because when you undo multiplication or division, you have to keep the sign. So I have to multiply both sides by negative 2. So I have here negative 2 divided by negative 2 is 1. So this leaves me with a d on the right-hand side. And on the left-hand side, negative 2 times negative 11 is positive 22. So d equals 22. Again, I can test this out. I have here negative 11 equals whatever d is divided by negative 2. And we see that d is 22. And over here, what is positive 22 divided by negative 2? And that's negative 11. So we see that this is a true statement. Okay, so in this section, you want to test yourself, pause the video, work out the equations, and then unpause and see if you got the right answer. First, we have here x plus 17 equals 40. X and positive 17 are on the left. I need to get rid of positive 17 to get x alone, so I need to subtract 17 from both sides. 17 minus 17, that cancels out. Leaves me with x equals 23. Next question, 10 equals 21 plus y. In order to isolate y, I need to get rid of this 21. It is a positive 21 because there's no sign in front of it. So I need to subtract 21 from both sides. 21 minus 21 cancels out, leaving me with a y on the right-hand side. And 10 minus 21 is negative 11. Next question, z minus 5 equals negative 3. In order to get z alone, I need to get rid of this negative 5. So I need to add 5 to both sides. Draw my line across. Negative 5 plus 5 cancels out, leaving me with z on the left-hand side. And here, negative 3 plus 5 is positive 2. 16 equals negative 8 plus e. In order to isolate e, I need to get rid of negative 8. Remember, in these, some students get confused because of this plus sign. They think they have to subtract. But really, what you have to pay attention to is the sign in front of the term you're trying to get rid of. So this is a negative 8, and the way that I eliminate a negative 8 is by adding 8 to both sides. So negative 8 plus 8 cancels. This leaves me with an e on the right-hand side. And 16 plus 8 is 24. Next, we have negative 3g equals 21. Remember, this means negative 3 times g equals 21. So we have to undo multiplication. And when we undo multiplication, we keep the sign. So the way we undo multiplication is we divide. So we're going to divide both sides by negative 3. Negative 3 divided by negative 3 is positive 1g, or just g. And positive 21 divided by negative 3 is negative 7. Next example here, 10h equals negative 55. Again, undoing multiplication by a positive 10, so I'm going to divide by positive 10 on both sides. 10 divided by 10 is 1, so we have here h. And here negative 55 divided by 10 is going to be negative 5.5. Last two examples here. A divided by 7 equals 8. How do I get rid of this 7? It's division, so I have to multiply. So I'm going to multiply both sides by 7. So 7 divided by 7 is 1, so this leaves me with A. And on the other side, 8 times 7 is 56. Last example here. B divided by negative 4 equals 4. I have to undo division by a negative 4, which means I need to multiply both sides by negative 4. So negative 4 divided by negative 4 is 1. So this leaves me with my B here. And 4 times negative 4 is negative 16. All right, I hope you understood this lesson and you did well on these practice problems.